All right. Well, hello, everyone. Welcome to our next session. And it is my pleasure to introduce Simon Didich to the stage. A little bit about him. He's an AI developer from Pathway, and his talk will be building RAG apps in YAML. From a little bit about him, from building the core of Pathway's AI engine to crafting high-performance Monte Carlo simulations at Credit Suisse, Simon knows how to make complex systems work. He's the wizard behind Pathway's YAML templates. He holds a PhD in approximation algorithms. So please, I would like to invite him to the stage. Over to you, Simon.
Okay, hello, thank you. Hello, everyone, and thank you for the introduction. On behalf of Pathway, I would like to talk to you today about how to run the pipelines using our solutions. The topic of the presentation is the data infrastructure for the live AI. And we'll go through some ways to run the pipelines and how to change them easily and customize them. So before we start, I would just like to quickly talk about Pathway. We are a startup working on AI pipelines, and our belief is based on the thing that in the future, most pipelines will be AI pipelines. So our goal is to make them as easy as possible to make. As for what we do, we are at the core, we have a data processing framework, processing in real time, and it's written in Rust, which allows it to be very fast and very powerful, but the whole library is available in Python, as that's much better choice for data processing, data analysis. And on top of that, we prepared some ready-to-use pipelines, the AI and RAG pipelines. You can just go to our page and run them, and this will work. And you can also customize them without touching any Python code. Our code is available on GitHub. We are open source, and we are gaining a lot of traction on GitHub. There are plenty of applications already built with Pathway, as well as some already commercial applications. So all of this is already being tested. And now I will switch to talking about the pipelines that we offer. And if you go to our page, you can check the templates page. And this is the thing I will focus on today. We offer a number of templates, and I would like to pick one as an example that we'll go through to see how to run this, what it does, and what is the responsibility of Pathway in all of it, where it sits in the architecture. So today we will be talking about the slide search. And before we go to the pipeline itself, I would like to quickly talk about motivation behind this one. We were reached out to create such solution, and this is for some people working a lot with presentations. So the story that we have is that we have Alice from marketing department, and she needs to prepare some materials about generative AI. And of course, if you already have something, it's better to reuse it rather than starting every time from scratch. So she knows that something was mentioned already in some past presentation. So she remembers that barriers to Gen AI were already discussed. But now the question is how to find it, where it was. So obviously it was in one of the presentations. Hopefully she started solve them, or probably the company, but that doesn't make the task any simpler. So you get plenty of presentations often without meaningful titles. And these are the PDFs, or maybe you have a PowerPoint format, but still that's something that is not easy to have a proper version control. So there can be a number of slides with the same name, but with some slides added, some removed. So looking through all of this is a pain. And now the goal is to make it easier. Mm. And this is actually a quite common pain. From what I'm being told, it's very common for the sales departments to reuse a lot of slides. You prepare a new deck for a new client, which is optimized for what they are interested in. But the solutions are the same, so probably some slides you want to reuse, and so on. Also, this would be from my personal experience in academia, but where you also talk about the same topic multiple times, and you have very technical talk at the conference about this specific topic. But then if you go to some conference with wider topic and you want to present this, you already use some slides with general results and replace the rest. So being able to find the slides you are looking for among all your presentations, it's very helpful. And this relates to finding information at all. So that's something that computers always were very helpful for us, that we don't have to remember anything, but can find almost anything. But now we want to do the same inside companies, just on the company's data. And that's something that RAG applications should be very good at. We can index just the data that company is interested in and look through that. And also by using Pathway, we are a real-time framework. So anytime you update your set of documents, the results will update. The new answers will take the new documents into account. So it's not that important to follow the updates, and you just need to query again and you will get the correct answer. And finding information, looking through all these slides, or in general documents, it's probably one of the most boring things to do. It's not someone's actual job, it's just some prerequisite. So if you can have some time savings here, then that obviously leads to some cost savings. And this is where our proposed solution comes in, and it does pretty much what it says in the name. It's aimed for searching the slides among all the presentation you provide. So if you have some folder with your presentations, then you describe what you're looking for the slide you want, and we find the slides for you. So this was motivation behind this problem. Now let's talk a bit more about architecture and what is Pathway doing. So what I have here is a typical RAG architecture, and it's a very generic one. It's not yet the slide search is just the standard RAG architecture. On the left, we have some indexing, from the ingestion of documents through embedding to storing them in some vector database or some other index. Then in the middle, there is a green path for the user queries. First retrieval, then creating a prompt, and using LLM for inference. On the right, there is also fine-tuning, which is optional. And if we take this RAG architecture and look at Pathway, then it's responsible for almost all of indexing and and taking care of user query. We still require some LLM for the inference, but we take care of ingestion of data, processing them, embedding, storing in the database, and so on. And the same for the user query, going to the retrieval phase, creating prompts. So all of this is part of Pathway. Now to our specific pipeline, which is a slide indexing pipeline. This is the architecture of this pipeline. We started with some data sources. It can be anything supported by Pathway. We started just example, the Google Drive or the SharePoint. These are then being parsed, and for the parsing, we use a multimodal LLM. The LLM could be of any provider as long as it's multimodal. It can be through API or run locally. But multimodal parsing is very helpful in this case, as the slides are much more than just the text on them. You also want to have a description. Possibly you want to be looking for the slide with some charts, maybe with some images. Maybe there is some change in visual identification of the company, and then you are looking for the green slides or something like this. So all of this can matter when you are looking for slides, and that's why multimodal LLM is important, because we get not only the text on the slide, but also the description. And with simpler parsing like OCR, we would probably miss a lot of that. Once we have the slide description and the text on the slides, we store it in the index, either the vector index or the hybrid index, whatever is chosen. And the querying part is quite simple. Once we get a user query, you retrieve the slides from the index. Okay, so before we jump to the demo, I will just talk quickly why Pathway is well suited for this task. So one thing is that it indexes in real time, so you get an update present in the results. Once you upload a new document, it will be indexed very quickly, and then you can query and get it in the results. We are also working on making this as best as possible in terms of accuracy. So selecting components in this pipeline, like choosing multimodal search or indices. All of this we are doing with the hope that we can achieve the best accuracy. Like I said, you can customize them as you want. I mainly talked about the LLM. You can use API or the local. But in general, we have these YAMLs. I will be talking a little bit more about YAMLs later in this presentation, but we have YAMLs for our pipelines that you can use to select the components you want to use. You can choose the connector, the parser, the LLM, the index, all of this. You just plug in another component and everything will work. The pipelines can be easily deployed. They can be deployed locally. On premise, I will be showing you something I done locally, and it's easy to deploy it locally, but you can also run this on the cloud, including the Intel Tiger Cloud. And if you want us to do that for you, we also have some hosted offering. And then finally, relevant for this conference, thanks to the collaboration with Intel, our pipelines were optimized on Intel hardware, and the product speedup was achieved with Intel GPUs. So if you are looking for something to run on intertable cloud, then Pathway is a very good choice. Okay, so let's start with the demo. This will be the most stressful part of the presentation for me, because I will do the demo live now, and I hope that nothing will break. So what I will be showing you is available on GitHub. I will just run the code that is there. So I will switch to my VS Code. I have everything here, and I'm using the default settings. It takes documents from the local file system. I just added some more presentations so that the results would be more interesting. And we can run everything with Docker Compose. And by the way, what you see right now is the YAML configuration for this template. All of this can be customized and changed. Okay, so I ran the Docker Compose. It created 3 services. The main one is the Pathway pipeline. But we also have some simple UI in Streamlit, so that it's easier to work with the pipeline. So let me go. I see some comments that everything is small. So if there is something I can do to make it better. Okay, so this is the UI. We see the documents that are being indexed. And let's start querying. So let's see what we get for the barriers to generative AI. Okay, so we obtained some results, the slides that are decided to be the best fit for this prompt. For each slide, we get the previous 2 and the next 2 slides is some context, the source, which page, and we can look at them and see what they look like. They are sorted by the relevance to the prompt. And if we click on them, we'll be directed to the PDF. Okay, so this is the slide. I hope it's readable to the share screen. And we can see that it talks about some, it even quotes the barriers for the Gen AI, and it lists some issues. So definitely a good match. The second slide has the title, the Gen AI Adoption Challenge, so probably also some barriers are mentioned there. Let's try another thing, applications of generative AI. So we have a different prompt, the answers changed. And again, we see some slides that talk about applications, so also relevant to the prompt. The first one lists some areas, the second, which areas will be most relevant. Okay, let's continue and check the benefits of generative AI. So right now I want to show what I was talking earlier, that often not only the text on the slide matters, sometimes we want to be specific what we want to show. So if we try the benefits of generative AI, the first one talks about value. So it seems that it's a correct result, and all of these are just text-based. So what if we remember that there was some slide with some chart, and we couldn't find this just by writing benefits of generative AI. So let's be more specific and say that we want a graph. The first one didn't change, but now the second one and the first one indeed has graph. So the fact that we were able to do that is caused by the fact that the parser returned the description that this specific slide contains a graph, and that enabled us to find this slide. So that's a nice thing coming from using the multimodal LLM. And okay, so let's go to the YAML configuration file. So you can let me see on the preview if you can see this. Maybe I will. Not sure if it's better, maybe not. But we have a schema here that we are sending to the LLM. So these are the fields that we are asking from the LLM. We are asking for the description, for the text, but also all of these fields are needed by the LLM when it parses the slides. So you can see that for each slide, the LLM should return the main color of the slide. So now we can query based on that. So I wrote blue slide with logo in the lower right, which is just a description of the slide. It doesn't talk about the content of the slide, just what the slide looks like, and we see that it works properly. So we indeed got the blue slides with logo. In this schema in the YAML file, and by the way, when you run this, you can edit the schema. If you want some other fields, you can add them, and all of this will be used in parsing. Here we have categories, and each slide belongs to exactly one category. Also, you can add the categories you want. You can change them and adapt them to your area of the topic of your slides. So we have some categories here, and we can filter based on them. So let's see how it works when we write gains from generative AI. And let's see customer success stories and use cases. Okay, this is the first slide that we get. Let me open it so it's bigger. And we see some very specific applications. There are 6 fields, and for each of them, we have some numbers about the way the generative AI benefited the use case. So it fits both the prompt and the category that we wanted. And instead, if we go to benefits and value proposition, we have the same slide that we already saw before. Let's see what it's about. And it talks how it will help with productivity of employees, but it doesn't mention any specific use case, any specific application. So again, a completely different slide, but we're able to find the one that is more relevant to what we want to show, whether we want to talk about value proposition or the use case. Let's remove the filter. And the last query I want to show you, let's ask about sentiments about the generative AI. And this prompt is designed to fail. So what we see is not very relevant, but that's because representations don't have anything on the topic. But now I want to add a new presentation. I need to I will copy a presentation that I have prepared to the folder that is being indexed. And if we look at the presentation that I added, okay, it contains the slide like this, which talks about strong emotions about generative AI. So that's something that fits much better the prompt about sentiments. Let's refresh. The new document should appear in the indexed file. It's in here. And then the first slide that we get is indeed the one that I was hoping for. We can also do this the other way, so remove this presentation. And let's refresh. Okay, and after removing the presentation, it's also removed from the results. So let's go back to the slides. So if you want to try this demo yourself, you can go to our GitHub and clone the repository and run this, or the instructions are there. You can also go to our page, and we have an online demo that anyone can try. So if you want to play around with this, you can do this easily. Now, in the rest of my presentation, I want to talk a little bit how to actually customize these pipelines. So, so let's say now we want to have a question answering RAG, just index document, use them as a context, and then answer some questions using this context. And we have a pipeline like this ready to run in the GitHub, but I will make some changes. So sticking to the topic that we had, the indexing slides and parsing slides, now I will want to use slides as my context. I will change the input source from the local file system that I used before to the Google Drive. We'll also see how to change the index. And all of this will be done just in YAML. I will start with the default YAML as it is on the GitHub, and then make some changes. So let's see quickly what it looks like. It's simplified code snippet, but we have an architecture on the left with indexing on the top and querying on the bottom. And then in the YAML, you will have components more or less in the same, relating to the architecture. So you will have a parser, and you can change the parser to something else. And it's enough to just change one component to change the pipeline. Everything else should work the same way. You can also change the index, the LLM. So here, I left everything the same. I changed the index, and the pipeline will still work. It just will be indexing the things differently, but it's easy to plug in another component and have everything working. Okay, so we'll see now this demo. So we start with the Google Drive with the slides, and here we have a YAML. We need to remove the file system connector and instead add the Google Drive connector. There are two things that we need to provide. There are some optional things to set, but the two things we need is the ID of the drive. It's in the path, so we need just to copy, and the credentials that are required by Google to connect to the API. These I had preferred before, so this is required by Google, and it's usually how API works. I changed the model of the OpenAI to GPT-4o so that we have a multimodal LLM, and I changed the parser to be slide parser. The default one was meant for working with text documents, and we want to parse slides, so this one will be much better for this application. Again, everything can be done with Docker Compose, and that is a simple UI for testing. The pathway pipeline exposes the REST connector, and the UI uses that to connect to the pipeline. So let's see what is the result of can generative AI increase productivity of software development. And we get some answer. It is indeed mentioned on one of the slides, and it quotes some numbers for the GitHub Copilot. Let's see another question. Is generative AI useful in biopharma? And this will be the same case as before. I want to show you that we will not get an answer right now. The context doesn't mention the generative AI in biopharma, but now I can add a new document to the Google Drive. It needs to be uploaded, and it contains actually two slides about biopharma. The first one talks about a drug candidate for the pulmonary fibrosis, and the second one is more general about future of drugs with generative AI. So right now there are some bases to answer this question. Let's try this again, and we get the answer about the novel drug candidate for pulmonary fibrosis created by generative AI. Now, the next question, who is Andrej Karpathy? And this question is mentioned in the slides. However, we didn't manage to obtain the answer. And now I will show you in the presentation that it's mentioned somewhere. There is a short snippet that Andrej Karpathy is a founding member of OpenAI. So what we want to do now is change the index that we are using in the pipeline. The default one is a vector index. Possibly the text search-based index will be better. If Andrej Karpathy is a very specific name, so you can just look for it in your documents. So I'm changing everything to use a hybrid index that combines a vector index and text search-based index. The letter index is based on the BM25 metric. This is the index we offer in Pathway. And then we have a hybrid index to combine them. Since this is changing the pipeline, I needed to stop the Docker, and I will restart the services. And as you can see, this is all in YAML. These are just few lines to change the index. And now we can restart this and see what is the difference. Okay, so everything started, and we can go back to the UI. Everything is still being indexed since we need to restart, but now we can ask it again about Andrzej Karpaty. And let's see what is the new answer. And we get much better answer, and it actually talks about him being the founding member of OpenAI. So the last thing I want to show you, it's the same for the slide search and for this one, and actually for all of our pipelines. We can use also curl to connect to the pipeline. And you get some response. Okay. So this is the end of the demo. And if you are interested in more, also we expose more endpoints than just answering. You can go to our website and read about this. And the last thing I want to quickly mention is accuracy. So we have internally a data set for testing RAGs. And this approach that we have a YAML for defining the pipelines allows us to quickly define a new pipeline with just a YAML and test it against the data set. And then if we have everything in ML flow, the YAML is also uploaded there. So we get we know what the pipeline did. We don't have to dump the whole code or the whole Python code that was used to define the pipeline. The YAML is enough, and it defines what is the pipeline. So I don't have time to talk about this more, but we have a blog entry that you can read with much more details about this, how we approach the accuracy. And if you need some help with getting started, then we are happy to help you. Okay, thank you for the presentation. You can go to our website or to GitHub and find more information. And now I think we are ready for some Q&A session.
Yes, thanks for your talk. I will go through the Q&A. So I'll have a few questions here. One is, are you using Streamlit Python module to show the web GUI, which I think was in your first demo?
Yes, we are using Streamlit to create UIs. It's very simple to prototype UIs. We are already mailing the pipelines, but it's easier to just see how they work if you have a UI, and the Streamlit is a very easy tool for that.
Right. Okay. And then another question is, are you using the same model for embedding and inversing during RAG? And
can you repeat?
Yeah, I think this question lacks context. Prakashan, can you do a follow-up? What does that mean? Which model are we talking about? While he is answering that, I have a few questions. I have two questions. In your demo, you've showed, being able to, on a search, show the inside of a PDF, right? Based on the content, you can do the search. I have a question. Like, a lot of times, practically, I will have many versions of the same file with the same content, right? Because they'll be versioned. When you do the search, can you find, how would you filter out the latest, only the latest? I don't want all the different versions. So if you say content, this and this, but then I'm going to share content in many PDFs, right? Because it's the same, it's the same version, right? Because I'm working with somebody or I'm mailing them, and I want to give them versions rather than I share it. Do you have a answer for that? How would that work? Just from a date perspective.
Okay, so just I will start that we don't have that implemented right now in our pipeline, but we are talking about the same slide looking the same in different PDFs, right?
Yeah.
So we can. The thing I'm not sure is where to put this, but we can have some deduplication of the slides. Probably before indexing could be a better place, and you would need to be able to group them by probably some preliminary thing would be if they have the same text, then check for the details. And the parser returns the text, so it's easy to check if they have the same text without calling an LLM or something. And if you have a candidate, you can check more details if they are indeed the same. And then just group them by and just return the last one by you wanted the last one by date, right? We have when we connect to the connectors, we have some metadata like when this file was modified and so on. So all of this information is in the system.
Okay, great. Prakashan has did the follow-up. When you do RAG, you first embed the data into a vector DB, and then we ask the questions. You use a inference model to answer questions from queries from the vector DB. That's what they meant by the model.
Okay, so we use the same. I'm not sure if I understood, but we use the same embedding model both in the indexing and then retrieval. If that was the question.
Yeah. If you click on the Q&A, you can see the questions straight.
Yeah, it's approved. Oh, it's approved. Okay, I was looking at the pending. Sorry.
Yeah, it's on the chat. Sorry, that's and on the Q&A too. If you click on the chat button, you can see Prakashan's questions. That might be better than me reading. Yeah, it can give you some context.
I see. Are you asking any question, or can I?
No, it was a problem, but I think you answered it because he said thanks.
Yeah, but I see the question by Himanshu. Can I answer this one?
Yeah.
So Himanshu is asking, would be nice to. Okay, it's not a question. It would be nice to schedule pipelines and generate YAML from it. Yeah, that seems like a bit harder. We don't have it right now, but it's indeed a nice idea to have. But no, that's not possible right now without the solution. Sorry.
All right. We have 2 more minutes for questions. I have one more that I put out there. I'm just gonna display these questions out here so that people know. Sometimes when I look at slides, I'm more interested in general subject matter, right? So let's say I want to know, I have these many slides. How many did I do on RAG? How many did I do on inference? How many I do, those kinds of things so that I can build up some metrics so I understand what content have I created thus far.
Okay, so when we are retrieving the slides, we get some score for them. So we could retrieve a lot of slides and then have some cutoff, and it's doable. The hard part is deciding what should be the cutoff for the retrieving, since these scores seem a little bit abstract. So we would need to do some research what is a meaningful score, but it's definitely doable.
Fantastic. Let me see if there's any more in the chat. I think you already answered. Do you also use modules like LangChain Llama in
No,
index?
I didn't answer this one. We have
Okay.
some integrations with LangChain and Llama index on the indexing part.
Mhm.
You can use embedded from LangChain and Llama index, and some also the parsers for the splitters. Yeah, and the components that we use on the indexing part, you can use the by
Mhm.
indexing I mean the right part, the
Mhm.
data ingestion up till the index, where you can use the components from LangChain and Llama index.
All right. Well, we're at time. I have one quick question. Like, what would be your call for action? Like, what would you want our audience to do? You gave a GitHub repo earlier. Is there something you want fork the repo, do some testing, things like that? Would that be a good call for action?
Yes, definitely. I encourage everyone to go to our GitHub, the LLM app GitHub. You can also check the main GitHub, the pathway.com/pathway. This is the GitHub for the pathway engine, but the pipelines are in the LLM app, and I encourage everyone to go over and try them and see how they work. And also play around with YAML. You can quickly swap some components and see what changes.
Yeah. Sounds great. Sounds like a great way to play around with that. Uh, well, thank you for your great talk, and I appreciate you coming on stage and telling us all about what Pathway has been doing. And with that, we have our next talk. We have a short break of 10 minutes. And Susan will be introducing Chris Calderon from Red Hat, titled The Full Circle Developer Experience Using Podman from Intel AI PC to OpenShift AI. So we will see you there after that break. Simon, it's been a pleasure. And thank you for taking your evening. I understand you're in Europe and spending that time with us. Really appreciate that. Thank you so much.
Thank you very much.
All right. Take care. Have a great evening.
Bye.